Okay, today we're going to solve logs for day one. So we're going to solve the simpler ones. Next class period, we will work on solving the ones with properties on them. Before we get started on solving these logs, I want to talk about what are we solving for and where it is located. So up on the top here, that's what we're putting. A little hole puncher punched out a little bit here, but we've got log base 5 of x is equal to 3. In this case, the unknown, what we're solving for, which is x, is in the argument. So we would want to convert this to an exponential in order to solve. That is the only way of freeing that x from the argument because all of this is one number. So you can't separate that unless you convert it to an exponential, and then you can free it from the argument. And so we would drop the 5 and switch, so that would be 5 to the third power is equal to x. 5 to the third is 125, so we've solved for the x. If we end up with a log that looks like this, our unknown is on the other side of the equal sign, its value. So that would be the easiest form. In this case, we would want to put it in the calculator. And that is alpha window log base. In the third case, your x could end up in the base. Again, all of this is one number, so we can't just separate it from the base, and that's where we use that definition. So we convert to an exponential. And that gives us x cubed is equal to 24. In this case, we have more steps to do because we need to get rid of the 3. Well, in our radical unit, we learned that we can take the cube root of this to get rid of it. If it was x to the 4th, we would take the 4th root. If it was the square root, we would take the, if it was to the second power, we would take the square root of both sides. So you would root the equation at that point in order to solve. So depending on where that x is, where that unknown is, that's what's going to tell you which method to use to finish solving. All right, so on our first one here, we've got log base 4 of x plus 3 equals 1/2. Our unknown is in the argument. So we need to convert this to an exponential in order to solve. So I drop my 4 and I get 4. These two switch, so that is 4 to the 1/2 power is equal to x plus 3. Now we learned in the radical unit that this right here is the same thing as the square root, so we could take the square root, or we can go ahead and square both sides. When we have 1/2 to the second power, that cancels. So we end up with 4 is equal to, and I need to square x plus 3, which means I've got a FOIL. So x plus 3 times x plus 3 gives us x squared plus 6x plus 9. Now we've ended up with a quadratic. Anytime that we have a quadratic, we want to get it set equal to 0. So I'm going to subtract the 4, and we get 0 equals x squared plus 6x plus 5. And we set it equal to 0 so that we can either factor or use the quadratic formula or graph it and find the zeros. This is an easy one to factor, so I'm going to go ahead and factor it. X times x gives me this x squared. And then we're looking for what multiplies to be 5 and adds to be 6. And so that is a positive 5 and a positive 1. Now, whatever makes this parenthesis 0 is going to be my solution. So I've got negative 5. And whatever makes this part 0 is going to make my second solution, x equals negative 1. Now, we don't want to stop there because we know that the base of a log and the argument of a log cannot be a negative. So those are undefined. So we want to take this negative 5 and plug it in to make sure that it does not make it undefined. Now, negative 5 plus 3 would make this negative 2, and we cannot have a negative argument, so this is not a true solution. That is considered an extraneous solution. So that's extraneous there. So our only solution would be x equals negative 1. All right, for our second one, we've got the natural log of x plus 4 equals 3.8. The natural log, if you remember, is a log with a base of e. And again, our unknown is in the argument, so we need to convert this to an exponential. So we drop the base, and we said that is e, and then the switch, so we get 3.8 as the exponent, and x plus 4 is now freed from that argument. My last step would be to subtract the 4. When you're doing that, you cannot subtract the 4 from the exponent. This is in the place of the exponent, this is not, so you would not want to subtract that. This would be the exact answer since e is a number. It would be e to the 3.8 minus 4 would be the exact one. If you wanted to get a decimal approximation, you would want to plug that into the calculator. So you plug in the actual e raised to the 3.8 power, get out of the exponent. So I used my arrow key to get out, and then minus 4. And so x is approximately 40.701. We usually keep 3 decimal values for an exponential or log. All right, for our next example here, we have the common log. There's no base written here. When there is no base written on the log, we know that's the common log, and it's got a base of 10. So when I convert this to an exponential, that is going to be 10 to the 1.3 power is equal to 4 minus x. We're going to put that into the calculator here. 10 to the 1.3. That gives us 19.953 equals 4 minus x. Now we subtract the 4. The best way to do that is to use the entire value. Do not round until the very end. So I would just hit minus 4 there. And so we get 15.953 is equal to negative x. The last step to get rid of this negative is we multiply both sides times a -1 or divide by a -1. Either way, we get x is equal to negative 15.953. I really boxed that pretty quickly because I forgot to check it, but it does work. 4 minus a negative, those two signs cancel out, giving us a positive. So that does work. All right, for our next one here, we have log of x plus 2 in the base of 64 is equal to 3. Again, the unknown is in the base, so we want to convert that to an exponential. When we convert this to an exponential, that is our base, x plus 2. That entire thing is our base. And then we switch, so we get to the third power is equal to 64. Now to get rid of the third power, we take the cube root. And whatever we do to one side, we want to do to the other side. We do that because the cube root and the cube are going to cancel since they're inverse operations. And so we're left with x plus 2. The cube root of 64 is 4. If you don't know that, you can use the calculator to get that. Your math button right here will take you to the cube root of 64. Our last step is to subtract 2. X is equal to 2. Of course, I check it to make sure that it works. When I plug in 2 there, that will give me a base of 4, which is something that works. You could also check it by plugging this entire thing into your calculator that way. So we'll do that as a check so you can see that. That's alpha window, log base. And I put 2 plus 2 as the base and 64 as my argument. And we get 3, which is what it's equal to here. So we can see that it works. All right, we've got one more example here. We've got log base 2 of x squared minus 6x equals 4. I'm going to drop my base of 2. These two switch. As soon as I see this quadratic, I know that I want to get it set equal to 0. Now 2 to the 4th power is 16. I subtract 16 to get it to the other side. and I get 0 equals x squared minus 6x minus 16. My 16 looks a little stranger. Now it's ready to factor or do the quadratic formula or whatever you feel more comfortable with on solving a quadratic. This is an easy one to factor, so I'm going to go ahead and do that. X times x gives me x squared. So -8 and +2 multiply to give me -16 and add to be -6. Now what makes each parenthesis 0 is my solution. So 8 minus 8 would make the first one 0, and -2 would make the second one 0, because -2 plus 2. My last step is to make sure that those work. So I plug in that 8 here, and that would give me 64 minus the 48, which is a positive, so this works. And then I'd plug in my -2. That gives me 4. And then this gives me a positive 12, which is 16. That works as well. So this one has two solutions. 8 and -2 both work. Just because it was a negative doesn't necessarily mean it's extraneous. Remember, it has to make the argument negative for it to be an extraneous solution. So just to recap, base and argument cannot be 0. So if it or negative. So if it makes it 0 or negative, that is an extraneous solution. If it is anything else, it's going to work. In order to solve these exponentials, you change them to in order to solve the logarithms, you change it to an exponential in order to solve.